The following content has been provided by RWTH Aachen University.
Then there's hardware prototyping. So hardware prototyping, here's an example, and again, I'm going to pass that around in a second, is the idea is here that you basically have something that you want to hold on to. This thing, for example, simulates a little remote and has these buttons on there. It has even different screens that you can move to. I'm going to pass this around so you guys can take a look how that was made and check out how it was mechanically built from what it's made, like the components and the materials. This one in particular has a little slot in so that it can actually move different screens into the front view, as you can see there. The idea of why would I do a hardware prototype? Well, if the system is hard to imagine just by having software, then you want to build a hardware prototype. For example, this remote, I could do a screenshot of it, but it's just a different story whether I look at a screenshot on a computer screen or whether I actually have a device in my hand. I can imagine how I would press those buttons, right? So in this case, this makes sense. Early in the days of mobile computing, there was a device called the Palm Pilot. It was basically about the size of this remote we're currently passing around, and was a device that you put into, that we were supposed to always carry with you, before the age of smartphones. And it had sort of, your calendar data and your address book on it and so on. It was a mobile device, kind of like a smartphone. And the founder of Palm, the company that made this thing, did something very strange with his team when they designed the Palm Pilot. Before they decided on any technical questions, like what kind of display is it going to have, what's the battery like, and so on, he made his team carry around little wooden blocks in their shirt pockets for weeks. And those blocks were different sizes. And he asked his team to figure out what's the biggest size of a wooden block that you are willing to always carry with you in your shirt pocket. Because if it gets too big, too clunky, and you end up taking it out because it's, when you're sitting down or when you're going to lunch or something, then, so the founder of Palm said, we've already lost the game. He wanted to design a mobile device that would be so small that people would always carry it with them. And so he figured out, by giving people this different shaped and differently sized and also differently shaped wooden blocks to carry around, he figured out the perfect shape that his device could be, big enough, as big as possible, but still something people would always carry with them. And then he said, all right, guys, this is the wooden block that performed the best, so to say. That was the biggest block that everybody was totally willing to carry with them all the time. Whatever we build, whatever the technical features is, it's got to fit into that box. No bigger, not a millimeter. And that's a good way to sort of understand the importance of hardware prototyping, right? Because if you went and made it a little thicker because, well, then I can add some more fancy stuff or bigger battery, if it loses because people wouldn't want to wear it anymore, carry it around anymore, then it kind of loses its purpose. So and this was not something you could figure out in any other way, but really the physical experience of carrying this piece of wood in your trouser pocket or shirt pocket or whatever. Another reason why you might want to do this is if the physical interaction is really important. For example, you're designing a new mouse or maybe even a 3D mouse or something like this, then that's how you're going to do a screenshot prototype of that, right? Hard to do. We're entering the world of sort of industrial design here, and that's a whole different discipline. But just to understand what the value of those kinds of things can be when you're really designing a software product, you can have designs done in wood or foam core, which is a wonderful material to work with. Industrial designers use it all the time. Various kinds of plastics, styrofoam, or, and this is really a favorite, simple cardboard. Right? The prototype we're passing around now also uses foam core and cardboard for pretty much everything. Of course, since this is a physical prototype, it's takes some effort to build it, and you're going to be sitting down with glue and stuff and scissors and things like that, or filing down cardboard or foam core and cutting it. But it also, once you've made a design and you want to now change it, that's also a lot of effort, much more effort than changing a couple things on a software interface, right? So there is a price to pay for hardware prototyping. It's very physical and therefore analog and slow. So here's an example, though. Wired reported on the Microsoft Touch mouse how it was designed, and these are some of the foam core prototypes that were made of the mouse. So you can see that there was an enormous amount of alternatives explored, sometimes only differing in minute details, and all these were being experimented with, held in your hand, seen like how does it feel, how does it move, is it the right kind of design. And none of these were doing anything, right? They were just foam core boxes. They carved dozens of possible variations in so-called Ren board. This is like a low-density foam that is very easy to sculpt with. And there isn't really a way to sort of design the perfect mouse just by, with a CAD tool. You have to really hold it in your hand and feel it and figure out whether you've made the right design here or not. Now, fortunately, we've recently seen some advances in physical prototyping that help us, especially in the computer science area here a lot, because you can now 3D print stuff. So rather than having to, by hand make these models, you might be able to have a digital model and print that out. So here's an example of the Pebble Watch as a 3D printed prototype. The Pebble Watch is an early smartwatch with an always-on display, and it made quite a racket when it came on the market. And this was an early sort of prototype that was 3D printed, again, just to see how it would feel to have a particular size of watch face on your arm. Those things are, of course, wonderful because you don't need any physical skills to make them, as long as you can make a 3D model or get it somewhere, you can print it out. And also modifying them is easy. If I say, oh, I want the watch face to be a little narrower, well, you go in, you change your CAD file, you hit print again, and you're done. Right? So it might print a little while, but you don't have to spend a lot of time in the workshop with it.
This content was provided by RWTH Aachen University.